All right, thank you all for joining us. So I just want to thank you all for rejoining us for part 2 of an insightful discussion on critical minerals and geothermal systems. For those who are just joining us today, I extend a warm welcome. This panel was originally took place at the Geothermal Rising Conference yesterday, where we embarked on a journey to explore the connection between critical minerals, mineral commodities, and geothermal systems. For today, we have Simon Jowitt, who is the Director for the Center of Economic Research here at UNR. We have Dave Boden, who has been a researcher and part of the ore exploration industry for a very long time. John Woods, who has also been in the industry for geologic exploration and ore deposit. We have Erick Burns from the United States Geologic Survey, and then filling in for Alexis, we have Isabelle Chambefour from Geoscience New Zealand, who is an energy future theme leader with a background in ore deposits and geothermal energy. So before we get started, for the purpose of this panel, we speak of critical minerals as those of high importance to a nation's economy and security, and mineral commodities as minerals and materials sought for their intrinsic economic value. During yesterday's session, we encapsulated the diverse facets of this topic. We delved into the vital role both geothermal systems play in our world, shaping economies with the deposition of highly sought-after minerals, and addressing global climate and green energy goals. From understanding the geological intimacy shared by geothermal, epithermal, and brine deposit systems to the cutting-edge research and technology driving innovation in this field, our discussions were nothing short of enlightening yesterday. So today we reconvene this panel through the Pivot virtual conference, and I'm excited to announce that our format will primarily revolve around moderated questions and answers for this session. And it'll provide for an opportunity to dig deeper, exchange ideas, and gain insights between our esteemed panelists here. So before we field questions from the audience, we just have one moderated question to kick off the panel, and that is that yesterday we became well rehearsed in the ways that geothermal systems and economic minerals intersected with each other, whether that was geologically speaking, through research, or through policy. So what emerging trends or collaborative opportunities do you see have the potential to reshape either industry practices or government policies to benefit the industry or national climate goals? And anyone could go ahead and start off if they want to.
Oh, you guys don't go first, eh? Okay.
I can start off with.
Do you want to do? Okay, go ahead.
Yeah, maybe I should do a little introduction into this and kind of just blend it into what we did yesterday. I was reviewing the relationship between oil and gas, mineral exploration, and geothermal exploration, and there's some simple metrics you can use to measure them. So, for instance, in the oil gas industry, last year there were 1,957 drill rigs operating. This year there was only 740, and you can get this off the Baker Hughes site. That leaves 1,217 drill rigs that aren't being used this year that were used last year, right? So it'd be great if we could just repurpose those right into geothermal, right, exploration, but due to basically legislation and policies, that's really not possible at this time. The previous group addressed eases of permitting, but let me continue and compare this to the mineral industry. So in the geothermal business, last year we had 9 drills. In all of the United States, there are only 9 large production rigs working. And this year there are 11. So there's a lot of drilling capacity out there that's not being used. In mineral exploration, we measure our exploration by meters rather than a number of drills. We have a lot of small drills and produce a lot of meters. About 5 years ago, the company I worked for, we would, to be comparative somewhat with this, we had about 80 drills we used in a year, and we spent about $150 million. And most of those were smaller drills, but we usually had at least a dozen that could drill below 2 kilometers, so get a mile deep. And those most of our drills would be adequate for first phase geothermal exploration. So one company that I worked for Geothermal has 11 rigs working. We had 8 times as many drills replacing 2 million ounces of reserves for a gold company as the entire United States geothermal industry, right? So we need encouragement to change the leasing system. Currently, if you find a big geothermal deposit, you don't necessarily get to keep it, right? Because it'll go up for a competitive bid, right? So we need to make some headways into changing that so we can get these drills working, and that's been the subject of a lot of discussion in this meeting. So I thought I'd just throw that out, that having 11 production rigs working in a year is not going to advance geothermal very much. We need to have 100, right? We need to go up at least a factor at 10 because there's a lot of potential here. I think we could keep 10 times as many drills busy for 20 years and still not explore all of Nevada. So.
Thank you, John. Yeah. Isabel?
Oh, yeah, no, totally. I'm definitely not into drilling or anything. So, and I was not part of the panel yesterday, so it's going to be, obviously, I don't know if you discussed that yesterday, one of a great opportunity, and it may not be feasible, but it's in very, a little bit blue sky research. And some of it's a researcher that have been merging between the ore deposit science and geothermal by looking, for example, volcanic geothermal brine exploration, and in a way of reducing the costs of geothermal. That may not be feasible just because of the nature, but we're going to learn so much by sharing our common knowledge if we're going into those super hard, super critical resources, for example. So that's one of the aspects that I just wanted to flag, because it's really important. The geothermal industry, as much as the ore deposit or the ore deposit research, we are old industry in that sense. We've been learning from each other for a long time, and it's very exciting to see where now we have some new avenue and opportunity for research. From the potential that I'm seeing as well, one of the key things that's going to be very valuable is particularly for the extraction of critical element from geothermal system. First of all, it's going to be a lot easier if you're having a convective system. So that's limit quite a bit the geothermal everywhere in dry hot. That's going to be a challenge. But the other aspect that we need to consider is the different regulation in different countries between geothermal consenting and permitting and ore deposit. So I'm not familiar necessarily with the US. I know the mineral right, for example, in New Zealand, is different than the geothermal right. So it's one of its aspects that if we want to make this everywhere, that every country will have to adapt as well. It's a really gray zone, mineral extraction in some aspect in geothermal, for example. Geothermal can be on the water right, and it's not a mineral right. So it's all of this work that needs to happen everywhere from my point of view to make it global.
Thank you for those thoughts. Simon?
Yeah, I guess one thing that I would say unifies the potential for extracting any metals or minerals from geothermal systems in the minerals industry is uncertainty. We talk a lot about critical metals and minerals. There's a whole load of assumptions there in terms of what's going to be important over the next 30 years. We're hedging our bets that lithium-ion batteries are going to be the future, that those lithium-ion batteries are going to have certain cathode compositions, that they're going to be the same fluid batteries we use now. But there's an awful lot of other technologies which could come into play, and we need to understand how, instead of just saying, well, this is what the demand is going to be, we need to model the uncertainties around that and think about other commodities that could be as crucial and are present in mineralized systems and geothermal systems as well. So that's something that I think needs to be discussed more. There's an awful lot of people going out there and making statements about, well, we're going to need X million tons of copper, X million tons of lithium over the next 30 years. Is that actually the case, or what are the upper and lower boundaries on that depending on the technological mix? And I think that feeds into all of this because, if we talk about critical minerals from geothermal systems or mineralizing systems, we need to kind of industry is based on, predicting prices for a certain commodity and spending money to develop those commodities. And if those prices are wildly fluctuating and likely to be fluctuating for the next 30 years, we need to understand that and model that in what we're doing.
Thank you, Simon.
Yeah, I just want to piggyback on that, Simon, a little bit. Regarding lithium in the Salton Sea, the price of lithium carbonate now, I think it's about $26,000 per ton. Well, if we start bringing on a lot of lithium, how is that price going to fluctuate? And that's going to obviously impact the revenue of the company. So, I mean, when you look at what, I guess it's no longer Energy Source, but the Cirque's property there at Hudson Ranch or Featherstone, they hope to develop a 20,000 per ton, recover 20,000 tons of lithium hydroxide equivalent per year. And if you look at the current prices, I mean, that's $500 million, and it makes power then a byproduct. But maybe by the time they bring it on, that price is, cut down considerably. And that's going to impact, their bottom line and such. So you have to take into consideration those price fluctuations when we do this. So that's something that needs to be considered. I mean, it's blue sky right now, and I think it's a remarkable resource. And the other question that I think heard last time was what Lawrence Berkeley Lab is doing with looking at the depletion. Obviously, if you're pulling this stuff out, you're depleting it, and you're diluting your resource. How long is that going to last? That's another issue that we don't really know right now, and that could impact the economics and such. So anyway, I'll stop there.
No, very insightful. Did you have anything?
Sure,
Erick?
but I think I'd take a little bit of a left turn. So I listened to your question. It was a mouthful, and I think kind of what I took away from it is you asked a little bit about what opportunities do we have to work together and learn from other groups, and I'll focus on that a little bit. In USGS, we're forced a bit to now because the Energy Act of 2020, one of the 5 new assessments is we have to assess the potential for co-production of critical minerals and geothermal. Interestingly, I think we're in a lot better position, and so somebody's going to have to be my witness to Alexis that I said something nice about her, DOE. But we're kind of ahead because DOE kind of was recognizing that our minerals program was starting to collect a lot of data in the Great Basin, and we needed a lot of great data in the Great Basin for geothermal also. And so they kind of reached out and they said, yes, we want to fund some surveys that really help us understand much better. So now we already have a running start at it because of GTO, and now we have a legislative mandate to do this, and we have a lot of ability to collaborate within USGS to learn from each other already, right? We have teams that do both, and everybody's really collegial, and I think we're on a really pretty steep part of the learning curve, but it's an exciting part of the learning curve.
No, thank you for those thoughts. And so with that said, that was super insightful, and I love the diversity of answers that we received. But yeah, we were now going to move it to the audience. We do have Lauren online as well, moderating online. So if anyone would like to kick off the audience questions, we'd be happy to do that.
Don't all rush at once.
Lauren, is there anyone online? No, I also do have.
Oh, go ahead, because I was just making a comment about what you just said. I think one of also the opportunity is those two industries have been in parallel, but have never really worked together. And it's also the possibility of putting geothermal to provide energy for mining. That is because mining is going to be intense in the future as well. I mean, that's also, if we can target, sometime most of the mining could be close to active tectonic area or area where there is potential good geothermal exploration. And that's a little bit outside of a critical, but that will provide commodity for the mining industry in terms of energy, reducing their emission, which is something that they are really actively looking. So it's all of this aspect as well that we need to consider, not just in terms of, just what can we extract from the ground, but also what is the benefits that every industry can bring to each other. I think that'd be a really good thing. If it's, sorry to have interjected, but I've just thought about it.
No, that's beautiful.
Yeah.
Thank you. And at any time, the audience may raise their hands if they need to, but we're going to move forward with some, oh, never mind.
Yeah, thank you for the panel today and yesterday. My name's Cass, and I'm with the Berkeley Project Group in Canada, and quite new to the critical mineral space, so I don't know if this is the right group to ask this question to. But I'm working on a project where we've observed trace amounts of lithium in the geothermal brine. And I'm curious about any comments you have for the technology options, or really deciding, do we have enough brine? What are the lowest concentrations where it starts to become viable to be looking at extraction? Yeah, so any comments in that realm I'd be curious for. Thank you.
There's a reason why the Featherstone plant is being looked at first. First of all, they have about an average of 300 ppm lithium in that brine, and they have an incredible, I think it's like 5,000, maybe 6,000 kilograms per second of flow. So a tremendous amount, relatively, so the highest lithium concentration that I know in a geothermal brine, and they have really high flow. And that's why that particular facility is moving ahead with this project. And the other people, BHE, that's also in that area, is kind of waiting to see how they do, before they launch. They're taking more of a conservative approach. So it's going to be really interesting to see how this unfolds there. There's another group, Controlled Thermal Resources, that's also in the area, and they've got some leases and some, pretty optimistic ideas themselves. And so, Circ Energy, or energy source, it's going to be really interesting to see how it all plays out. They're hoping to have something going 25, 26. They've done a demonstration, and they said they hope they have something commercially going by that time frame. So that's not very far away.
Just to kind of follow up on that, I think the key thing is that the technology needed to extract the lithium from the brines. I mean, the majority of lithium production in the last 30 years has been from brines where you can concentrate lithium by evaporation, because those brines are in equilibrium with the atmosphere. Every other brine we've got, including geothermal fluids or anything that contains lithium, needs that direct lithium extraction, and that's we heard yesterday about some potential breakthroughs, but there's nothing been demonstrated as far as I know on an industrial scale as yet, and nothing, whatever you have needs to not impede the energy generation capacity of that geothermal fluid. So it needs to be a balance, and if you essentially, unless there is that breakthrough which can cope with the flow rates that Dave was just mentioning and doesn't impede energy generation, then, it's that kind of balance, because what you don't want to do is focus on lithium extraction and all of a sudden you're losing out on your energy generation capacity. So I think there's a lot of thinking about that balance, and whatever technologies. I don't know if there's a silver bullet, or maybe you might want to call it a lithium bullet, where you can do both. It might be that some geothermal systems, some brine, oil-filled brine systems, whatever system you're talking about, focuses on lithium extraction or critical metal extraction rather than energy generation. One becomes a main product, the other a byproduct. But we'll have to see how the technologies develop. And the same goes for lithium clays as well. We still wait to see economic industrial scale production from those other sources of lithium. There's a lot of lithium out there. The trick is getting it out.
Yeah, and I just want to comment, Dave, that 300 ppm lithium, that's huge. It's massive. But it's so one of the thing as well that I just like, for example, New Zealand, we have 12 ppm in average. So let's just forget New Zealand as a lithium source. That's just, I don't think that's gonna, it's really far from being economic at that point. But one of the key things is that they align that there's some test and some, I will say, exploration in technique into removing lithium as the chain as when they remove silica, for example. And so as we know, geothermal has a lot of issue with silica scaling. And so some companies have had to remove silica before re-injecting, for example. And so at the same time they're removing that, they're doing some filter and membrane, and they are testing now to remove some elements such as lithium and cesium. So that's not directly, the point of doing like the extraction, but that's a byproduct that will be, if the membrane is viable, that's a plus that doesn't cost that much more, if you want. So it's the type of thing really that maybe will be another source. But again, you need to make it economic on the global lithium market, which is at that sense, when you have that as a byproduct, it's just a plus, it's a benefit, fine. But to make geothermal for lithium extraction, that's going to be very challenging economically.
Awesome, thank you for those comments. So we do have a question from the online audience. Our question is, what are the panel's perceptions of the various types of DLE tech in use? So DLE is direct lithium extraction tech in use. And I would also like to additionally add any type of tech that we use for mineral extraction in general. But the online specific was DLE tech.
I'm not an expert.
Well,
So.
okay, I'll go first. But I mean, we heard some examples from the Department of Energy on essentially kind of technologies that can scale up. Everybody in the DLE area is pretty hush-hush. They don't talk about it much. It's all proprietary. We're putting together a special volume of lithium papers, and to try and get anybody to talk about processing in a public forum in detail is difficult. And whenever you have things like that, it always makes me a little wary about how viable all these different technologies, be they membranes, be they ionic exchange, whatever it is. I'm not going to say it's not going to work, but I just want to see it kind of scaled up, and whether that happens first at if we incorporate things like lithium extraction from clays and direct lithium extraction, then I think we need to see the technologies in action. If you look at mineral systems, we had similar things in the 1990s with nickel laterites, which are hugely problematic to process. And that meant that actual processing step basically made companies go bust because they couldn't actually get the stuff out. It was high grade, relatively high grade nickel, but it's in the wrong form. And if we have, I can't exactly answer the question because I don't know the full extent of the technologies out there because everybody's being a bit quiet. But I'm not skeptical, I'm just quietly cautious about how quickly these things can be developed and how they scale up to the actual scale we need to effectively extract lithium from geothermal systems, oil field brines, clays, and so on.
Well, I think your question is what kind of cutoff grade you would need. You said you had a trace, and you could probably research that. I think there's some information you can probably find online for the Salar de Atacama or Silver Peak, Nevada. And a trace isn't nearly enough. And I think generally people don't get excited until they see about 40 parts per million or so. Can you guys correct me if you're wrong? The extraction costs are kind of high. And this is dependent, the grade is dependent on all of your technologies. How deep is it? Your pumping costs go up astronomically if you're pumping from deeper levels, right? It's almost logarithmic, right? So there's a lot of parameters that could go into that. If you had some kind of Black Sea thing where the entire ocean had a lower level, you might be able to precipitate a salt and do even a lower grade, but you need a really specialized environment to get below that type of grade. And a lot of this stuff is available online, so you can see what other people are doing and then see how yours, and some of them have generalized costs, so you can see how that would compare with yours.
Thank you. Any other comments from the panel for that question? Okay. Any other audience questions? Oh, right behind you.
Afternoon. My name is Kyle Hosfett with Devon Energy. We're an oil and gas producer. We produce around 1 million barrels of water a day in the Permian Basin, with lithium content ranging from 30 to 50 parts per million. My question is, we're looking at DLE like it sounds like a lot of other people, but can you talk through the pros and cons of taking our water to zero liquid and do full solids, and some of the techniques that are available for separation of the various minerals we have in fully evaporated water to steal them with solids?
I'm not an extraction technique, so I just like,
So it's down to me again, is it? I mean, the kind of classic ways of the brines we currently use for lithium extraction. There's a very well-developed flow sheets that are available. You can get them online from the companies themselves, which indicate what they add and what they take away at each stage of the. I think it's Silver Peak, Clayton Valley. It's 2 years of evaporation it takes to go through that stuff. But these brines that we're extracting lithium from here in the state of Nevada, up down in South America, they're in equilibrium with the atmosphere, which means that they've worked. They formed relatively recently, and they're in such a way that that lithium is concentrated via evaporation. The trouble with the oil-filled brines is that if you leave it to evaporate, you don't get the lithium concentrating, you get other stuff concentrating because it's not in equilibrium. So there may be other ways of actually developing evaporation techniques or some other additives you need, but I don't know of any huge developments other than the areas of direct lithium extraction. I may be missing something, but I think there's a lot more kind of research needed in terms of the chemistry of those fluids and how they react. Evaporation won't be the answer. It'll have to be something else or something in combination with evaporation. Maybe you precipitate something out and then put it in a different type of solution and then try and concentrate it via evaporation that way. But I think there's a lot more research and development needed to work out how viable those are. And then that feeds into the uncertainty over lithium because, as Dave mentioned, the lithium price is pretty volatile because it's still a small sector compared to copper. So is it worth for you the investment for, in terms of actually examining the lithium potential of your waters? And there may be other elements in there as well, because remember, we're talking a lot about lithium, but there's an awful lot of critical metals on that 50 element list the US has. So there may be other things in there which are present in different concentrations, but may actually be easier to extract than lithium for your waters. So I think having a look at them in detail, having a think about the way these things behave as you do go through the evaporative systems, maybe learning from brines or just other kind of natural systems where we see waters evaporate of different types, and learning from those and seeing what you might be able to do, because lithium is one option, but there's an awful lot of other metals and elements out there that we need for the energy transition. So I think to focus on lithium alone is maybe not the best way forward for all of us.
Yeah, those brines down the Salton Sea are also very enriched in zinc, manganese, and silver. And gosh, it's been maybe over 20 years ago, Cal Energy spent $300 million trying to recover zinc and silver, and it didn't work, and it ended up costing them a write-off of about $350 million. So it's still very much a work in progress as far as I can tell. I wish, that was a great summary there given by Simon and such, but I'm not a process engineer, and that's really what these questions are about. I'm just a field geologist basically, and that happens to work with, epithermal minerals and geothermal and such. But I'm as interested as you on how they're going to do this.
So I actually am a geochemist, so I would take a sample of your brine and send it to a hydrometallurgical lab and have them tell you how they can. I'm sure they can actually extract these metals, but usually it's way too cost prohibitive. So, but if the big cost of getting the water there, you've already done it, right? So your pumping cost is one of your biggest costs. And they might have some kind of small processing plant. These things are treated in different ways in lots of places. So I would just you can get a bid for a complete analysis and then some extraction tests. And I don't know if you have anything in there more valuable than lithium, but it's worth doing the test work just to see what the cutting edge professional people, and they have lots of secrets they won't put in these meetings till after everybody knows about it, right? So I'm pretty impressed with a lot of the labs I've worked with. So.
Thank you for that, John. And actually, to pose a question from some of the comments from the panelists, I created this panel to be very diverse and encompass all sorts of commodities and critical minerals and materials. So with that said, this conversation, I think on its own, just, lithium has been a word I think I've heard a million times today. So if we could, I would like to ask the panelists are there any other materials and or minerals that we're missing in this conversation that you think that should be more focused on other than lithium? If you have like 2 or 3 on the top of your head, or, yeah.
I don't know. Simon, what do you think? Rare earth? I think rare earth.
Rare earths?
Yeah.
I'd say tellurium, germanium,
tellurium
gallium.
as well. Yep.
Those things are all present in fairly high concentrations in geothermal fluids from Stuart Simmons' work and others. The rare earths, I mean... The
rare earths are generally very dilute in geothermal fluid, but I'm just thinking in terms of critical element, what is the next step?
The rare earths, if you extract them, they'll all come out together, and then you've got to separate them, and that's a whole other nightmare. Yeah. So I would say tellurium, gallium, germanium, maybe selenium. The kind of things actually we see in mineralized systems and use as indicators, because they go along with the hydrothermal fluids. So these elements are not that well known, but they're crucial for things like semiconductors, for cadmium telluride, solar panels, and so on. So there is increasing demand for all of these things. But whether they're economically viable to actually develop the extraction from these fluids or not is another matter. There is the policy, the critical metals. So in the US, you have policy advantages for actually extracting them and so on in terms of permitting potentially, in terms of good news value, because if you're extracting tellurium to put in a solar panel, and that's good news for your company and so on. So there's all sorts of different forms of value that these critical metals can take, but you need to work out whether those values are actually equivalent to the cost needed to extract the things.
Yeah, I touched on yesterday about geothermal, hydrothermal processes that lead to, economic concentrations of, recoverable, in this case, gold and silver. And as Simon was saying, these systems are anomalous in selenium, tellurium, but they're sub-economic in terms of their ability to get extracted, essentially. It's the same old thing with I looked at so many different fossil geothermal systems that were anomalous, but they didn't have the grades or the volume to make it economic for extraction. And so that's something that has to be considered with these things. These systems are anomalous in these elements, but they're not necessarily, at this time, recoverable. And there'd have to be some significant advancements to make that a go.
I mean, there's sorry. I'll let Erick. Go ahead.
You probably, if it's a responsive thing, you should say something.
I was just going to say, there's also some oddballs in these systems. You mentioned silica. If you get high purity silica out of your geothermal system, then that's really valuable.
It is very valuable.
So
yes.
it just has to be the right purity for using in certain kind of specialist techniques. But there's all sorts of things that are in demand, or even if you can get silica out as aggregate in an area that's aggregate deficient, there's all sorts of possibilities to enhance the economics of your system. But didn't mean to interrupt you, Erick.
No worries. I was even going to take a step a little bit further out. Somebody showed a slide yesterday about, depending on who you ask, these are the critical minerals, right? So we have all of these. It's a much broader question in some ways, right? Is you have these things you need, or in an emerging way you figure out that you need. you also figure out we're at a time of really tremendous ingenuity and growth and cleverness. And what's sub-economic today might not be sub-economic tomorrow. USGS uses this thing called the McKelvey diagram. I don't know how many people here are familiar with that, but it kind of breaks it into sort of a, I mean, there's different ways it's sliced, but it's kind of discovered and undiscovered, developed versus undeveloped, economic versus sub-economic. We always wrestle with, when we do an assessment, do we only, talk about what's economically viable today, especially given the last hydrothermal assessment we did was in 2008. So 15 years ago, it's time for us to update our assessment. We recognize that. We're working on it. But if these things were more living, breathing, and we could update them on the fly, it might be really, really interesting. Yeah, I think I kind of leave, I heard a lot of sub-economic, but on the flip side, I think there's a lot of kind of hope. People are doing clever things, right?
Yeah, we haven't done much of this in the past, and I think we're just in a new era of just looking for what we can process and how we can process it. But when I did geothermal sampling or any type of well or water sampling, you fill up your Nalgene bottle to the top so you have no air in it. And so I ran a mobile lab as a test of production labs. And what happens is when you send a sample in, it exhausts a vapor phase. So I would do an immediate analysis right from a wellhead, and then I would save one sample and send another sample to a commercial lab. And we used a lab in Denver, so it took a few days to get there. A lot of my samples exhaled a vapor phase that was equivalent to 15 or 20% of volume, right? And the sample bottles would just bulge out. I don't know why they do that. But we analyzed that vapor, right? So we didn't do the acidification. We had a little different system. We measured immediate pH, and then you have pH changes. We didn't care to stabilize it. We could still analyze what's in it, irrespective of pH in most conditions, right? So I would recommend when you take samples, sample the vapor phase, and even if I had an oil well, right, you might find large volumes of ammonia, hydrogen. Like if you were 4 or 5 ppm hydrogen from your oil well, you're in the money. You could just collect that, right, and then sell it to hydrogen fuel cell people. And it might be a small project, but you just collect it, and we've done this a lot of times in a lot of different commodities. At the Slaper mine, we had way less than 1 ppm mercury in the ore. But under the laws, and we had some mercury detectors at the mine, and occasionally we would detect it. And we put in a collecting system. So the collecting system, this was engineered carefully, was just some pipes that went in a loop. It cost us about $100 to make it. And then we had a nozzle that went down into a flask. They sell mercury in 76-pound flasks. And it took over 3 months, but roughly every 3, 4, 5 months, we'd get 76 pounds of mercury, right, and we'd sell it. When we filled up the bottle, we had a company come in and take it, and we were making a profit. So we would just ventilate our mill, having the air come into the refinery area where most of the people were, and then it would circulate back around into where the ball mills and stuff were and come out through the top. And so there's a case where for $100 we collected the mercury, and really only the people around the mill had to wear a respirator. So if you had a few ppm hydrogen, for instance, you could do the same thing. You put in a hydrogen collector, and then you come back every 90 days, and you got a few $1,000s worth of product, right? So we need people to start doing this, and go talk to those high-powered hydrometallurgists and actual scientists, and make it a challenge. Hey, can I make any money doing this? What is this? But I think it's just as likely that you'll get valuable products out of the vapor phase. And I've been doing ammonia testing, exploring for gold, out of just soil vapor. And there's some big numbers just coming out of the soil. And the higher the numbers get, we get to an actual fault zone, and we're going to assume that fault's going to have gold somewhere deep, right? So I think there's lots of opportunity here. You just have to go realize it, right? I'm challenging you to go and make millions of dollars harvesting something from that well you never thought of. So.
Thank you, John, for that. Any other comments? We do have a question from the audience, but any other comments with that?
Oh, I just want to make a quick comment about what Erick was saying earlier around the critical, and I know you discussed that yesterday, but the importance of critical mineral, critical element, and how it's going to be dependent on the energy transition strategy that each country is going to take. And it's not, and it's probably because I'm not from the US that I'm thinking, because it's not a solution fit for all. And we really need to think it's not going to be a massive decision. But I think a lot of countries right now are really pushing for, I hope so, a lot of, obviously, energy transition and how to fund that. Very few are actually thinking in the line of how that's going to fit into the primary resources market, how that's going to fit into the overall, element like strategy. And this is a very important things, because they're doing right now some strategy on how many wind farm, how many solar farm they're going to be able to build based on the market that we have today. So, for example, the copper price may explode, or which probably not, but I'm definitely not an economic specialist in this type of aspect. But this is really a key in countries, particularly small countries that do not have other possibility, for example, than fossil fuel right now. Those kind of parameters are going to play really heavily in the balance. And that's where I see the development of a parallel between geothermal and not necessarily critical element, but that will be sustained. That's a overall system complex that needs to be understood. Just wanted to make that case.
No, thank you for that. And then we have a moderated question from Lauren.
Hi. Going back to yesterday's panel when we were speaking on the desire to continue with our expansion of data collection, and that we're now in a robust phase, but maybe we could have started earlier. What are the cutting edge data collection techniques that we're starting to see now, the more initiatives on that that are expanding upon the methodologies that we've had in place, and how are we seeing those being integrated into the geothermal and critical mineral space?
Term of data, I think most of the time the data, if it's just in terms of knowing what's your, the content of mineral that you have in your geothermal fluid, spring, source, wells, or things like that, I think most of the country will be quite well known. There's the data that do not necessarily exist is some of the kinetic and how you actually releasing some of those elements from the rock, which is quite important in terms of scientific knowledge to acquire. And so what is the optimal fluid condition that you will have to extract some of this metal directly from the rock? We know a lot from or deposit in some aspect, but they're already in the rock if you want. But if you're thinking in terms of supplying and having some of this mainly based on water-rock interaction, we need to understand how those reaction will work. So that's one of the aspects for me that that's one that I can think on top of my head right now, but you guys have other idea?
Can you repeat the last part of that question?
Your microphone? Oh, sorry.
Yeah, and just in terms of the new or improved data collection systems that we have, the different ways that we are collecting data, can you point to any of those that seem to be show a lot of promise, and in what ways are they being leveraged in this particular space of geothermal and critical minerals?
So are you talking about kind of the pre-competitive data as well as the data that Isabel mentioned? So like geophysics and things like that. So I
Geodawn, perhaps.
Yeah. So the Geodawn and things like that. The acquisition of lidar and aeromagnetics over a fairly large part of Nevada and adjoining states and so on. But I think there has been breakthroughs in mineral exploration in terms of developing, for example, superconducting magnetic systems that can actually see through cover and things like that. But I don't know of any application of those approaches to geothermal exploration for blind systems, and I don't know whether they'd be economically viable, because we were looking for, we've used it before in nickel exploration, looking for magmatic sulfides, and you need essentially dewars of helium, which cost $1 million each to run these things. So, you know, you need to be pretty sure there's something in that area that you're interested in, and I'm not sure whether we are that far advanced on blind geothermal exploration to actually be able to predict that and therefore make some of these more advanced techniques to focus on specific areas viable or not. I don't know. I'm going to throw that to the rest of the geothermal panel here. So,
And I think we have plenty of regional data. You know, most of the data we collect is like the Great Basin, you know, statewide large data packages. They show lots of anomalies, and I see hundreds of anomalies that I would have gone and followed up years ago, but nobody's done it. The regional surveys are usually, if they're airborne, they're wide-spaced lines. They miss a lot of stuff, and it'd be better to go identify the best targets. I challenge the industry to do it right now. Take all the data we have and identify the best 100 targets. Then go to those areas and do detailed surveys, right? And there's a lot of types of surveys people don't generally do that actually work pretty well. And one I spent a couple $1 million. In Mexico, you can't always get on your property because there's a gang war going on or something, so we just fly airborne surveys, right? And so I spent $2 million on one, and I did a radiometrics for potassium on one survey, and even the geophysicist said, oh, that's not going to work because, like at Sleeper, a major component is adularia, and that's actually radioactive. If you go out to Sleeper with the right tube in your scintillometer, it'll just light up on the road as you drive by. So that's a good exploration tool, and they have airborne versions of that. So I flew over my targets, and the targets themselves were hard to see, but the float from the erosion, I had huge alluvial fans that were just lighting up really well, and I was so happy with that survey. And there are a lot of other techniques you can use, but they're expensive, so you don't want to do them all over the state. It would be many tens of millions of dollars, but you could do it in your target area, right? And a survey in a target area, and I just do the full component of these various techniques I was using in Mexico on each target area, right? And gravity magnetics and in detail, right? CSAMT, right, Tellurix, and et cetera. And then, so when you look at your anomaly on the statewide map, you go, oh, I'm gonna go drill that little dot, and you get out there, and it's 20 kilometers by 20 kilometers, so where do you start? It's not, when you get there, you realize, wow, this is actually, that little dot's kind of big, right? So that's your target, you do your survey, you'll identify major structures and all this stuff through your tools, and you can do them just one at a time or as you need them, because that's the way I do it. I don't run everything. I just go out and look at the ground first and say, well, I need these 2-3 types of surveys, and then I just go for it. Like at Tungsten Mountain, I just did one ground IP resistive survey. That's all I needed to get a vector to make a discovery, right, in like the second or third hole.
So if we think this is a good idea, I know someone we can trick into it. So there's a geologist at USGS who's really interested in thinking about fluxes of hydrogen, geologic hydrogen fluxes. So he keeps asking me, how do I get out? How do I get connected to the geothermal community and get to resample their wells and things? And it turns out that this becomes an amazingly time-intensive process, right? So if we can figure out how to effectively get samples from sites and get them in and analyzed. He's trying to get a postdoc right now that I think he's going to try to push through this. But he'd love to think about hydrogen, the critical minerals, and then I've kind of said, well, if you analyze my samples, I'll loan you some machine learning horsepower to figure it out. So, I mean, we have an interest. We're stretched thin, you know, as USGS. So, but we're happy to talk if this is like something that the industry and the community wants, is a sort of a new supercharged sort of chemical kind of understanding of, we probably start in the Great Basin again, but and we look at all the existing data. There's a ton of existing data that has to be gone through, that's in the GDR, that has to be properly pulled out and qualified. But within that context, there's probably a lot we could learn, and add a bunch of these new, interesting minerals and elements and all of it. So, so let me know if you want to try to trick somebody into this, or you want to even offer that he or his postdoc can come out and sample your water and tell you something about it. I can make a connection.
I think just leading off what Eric said, and also Isabel, I think just having a database of geothermal fluids, maybe from producing wells, but also other just kind of natural hot springs, and actually taking that further and thinking about what Isabel said, and learning about where these things come from, why they have the elements and species in them, like hydrogen and so on, that they do, and understanding that to basically take that knowledge to understand the potential of geothermal systems before as you kind of discover them. So, you have a geothermal target, it's in a certain area, the geology of that area. You can then predict, and based on the knowledge you gain from previous research on geothermal and mineralizing systems, what it might contain in terms of critical metals. And that could also, or even things like silica, which could be a problem. So you're actually kind of thinking about both opportunities and challenges in a given area that you expect to find in the geothermal systems when you discover them. So it's that kind of bringing things together and having a holistic kind of viewpoint or a holistic approach to understanding these things that I think is going to be vital in terms of really making the most of geothermal systems into the future. We're good at understanding the structural controls on them, but I think taking that further into finding blind deposits, and then also taking that further into understand these, the systems themselves, why some of them are enriched in lithium, why some of them are enriched in tellurium, how does that relate to temperature, how does that relate to other fluid, other elements and species in the fluid and so on. And I think, the kind of comprehensive studies we've seen of mineral deposits elsewhere could well be done in geothermal systems, and it would give you an awful lot of insight into the way these things work.
Thank you for that insightful comment, Simon. So we are closing in on our time here in our panel, so I'm going to close with the same question that I closed yesterday. So if you want to reflect on the answer that you gave yesterday, or give the same one that you gave yesterday, feel free. But so for the panelists, if you could change one thing to enhance one or the other industries or both industries, whether it's related to funding, policies, research focus, education, whatever it may be, what would you prioritize? Again, for the betterment of both industries in terms of growth, but also meeting our goals in terms of national security and climate goals. I mean, Eric, you can go first since you went last time.
Sure, and I'll give the same answer, sort of. Maybe I'll say it better, though. We'll see. So I think something, and we're working towards this as a government, is trying to do better with the permitting and the timelines, right? There's a federal interagency task force that still meets, even in response to, they put out a report, I don't know if you guys saw it, but that they can give Congress and say, we need to do better on the timelines, we need to do better on the permitting, we need to all of this. And so, and even at this meeting, my GTO colleagues and my BLM colleagues have wanted to pull me aside to have little discussions about how do we do better, right? How do we go faster, sort of thing. So I think that's kind of, we're working on it. Believe us, we talk about it all the time, and I guess you want more than talk, though. So I suppose that's where we need to do better.
Well, I'm going to pivot from my answer and kind of echo what Eric just said, because one of the things that I noticed from, there was the America Recovery Act after the financial crisis, and there was a big surge into geothermal, and then all those production tax credits went away. And I was sensitive to this because we had developed a geothermal plant operators program. We were putting students into geothermal as geothermal operators, and then suddenly there were absolutely no jobs, and the whole program became dormant. And the problem I see with this country is that we've never had a consistent energy policy. It just vacillates from one administration to another, it seems like. So I am somewhat bullish about this IRA act, because we got 10 years supposedly to work with and such, and maybe that's what's needed to really catalyze investment and progress in our industry here. So, and then I mean, yeah, permitting processes, yeah, exactly. Or just the uneven, oil and gas get certain special treatment from NEPA that geothermal does not. When they drill our wells, we have to go through, an EA or an EIS, and oil and gas does not. I don't understand that. I mean, those are the sort of inequalities that need to be addressed here, and I'd like to see those things taken away. And then also, the California Public Utilities Commission came forward and said, we want 2,000 non-intermittent megawatts, excuse me, by 2035 in California. And so governmental policies that promote those sort of things would really be welcomed. I'll stop there.
But then fracking is not allowed in California, so EGS systems are almost null and void, right? In California?
Sorry?
I think California also, didn't they prohibit hydraulic fracturing, or am I mistaken?
Well, I don't know if that was for just oil and gas. I don't know if that applies really to geothermal, but that mandate by the CPUC was, I think, going to be instrumental for promoting geothermal development. And the whole issue with CAISO and the whole, up and down of intermittent energies has caused quite a problem with the grid.
All right, we've got roughly 3 minutes left, so.
I think it's pretty obvious with 10 or 11 geothermal drills operating per year, you're not going anywhere. And the regulatory environment ought to change such that you have at least 100 geothermal drills per year.
Just a quick note, as permitting and legislation has already been addressed, understanding the system, if you're going to drill into rock, so we're going to need geologists, that's for sure. So educating people, recruiting students in first year, because it's really important. Right now we have a decline in earth science student enrollment, like it's a worldwide trend. We're going to need more of them. So it's a really important thing. And then understanding the system, because you're going to, if you're doing an EGS, if you're doing thermal stimulation, tensile, whatever, you don't want to use the term, the F word, when you want to do that, you're going to have chemical reaction that happen. And we need to better understand that, as Simon said, like just, so to limit the risk. But education will be my first priority.
I'm going to say collaboration rather than competition. The earth sciences, well, we're facing a huge number of challenges related to the energy transition, geothermal, and the aspects we're talking about here, mineralizing systems, find the metals and minerals we need, find the renewable energy we need. The biologists and the physicists are really good at collaborating. Look at the Human Genome Project, look at CERN, really big developments, really big collaborations. Earth scientists are not very good at coming together and doing that. So, why don't we have a Human Genome Project to solve the supply requirements for the energy transition, including geothermal power, including mineralizing systems. There's an awful lot of things and areas we dovetail together. We're doing quite a lot of this with Earth MRI, as Erick mentioned, but we can make this bigger. We can have more collaboration between USGS, Department of Energy, and just actually bring industry together as well and say, right, well, what do we need to solve all of this, and how can we go forward, and how can we do it together to actually benefit everybody financially, economically, sustainability-wise, and for the climate change mitigation and so on.